Assalamu alaikum. Yes, children. Yesterday we started exercise 2 of the triangles chapter, and we solved up to question number 5 yesterday. I hope you have understood those. You were yesterday also told, in case you have any queries, you must call me to get those queries cleared. Doubts can be cleared only by that way here, because we are not face to face. Let us proceed with next question of this exercise. We have question number 6, and the diagram of the question you have on the textbook. To draw that diagram, I shall read the statement in the meantime. It is triangle ABC, an isosceles triangle in which AB is equal to AC. Side BA is produced to D such that AD is equal to AB. This part of the statement, as I yesterday also told you, earlier also I have said, will be the given part of this statement. Up to this you have given. And it is followed by what we have to prove. The word show is there. This refers to the to prove of the question begins from here. You have to show that angle BCD is a right angle. Must have drawn the diagram. Here is it. A triangle ABC. It has AB equal to AC. One short line on each of these shows these are equal. BA side is then produced. How much you have to produce it? To a point D such that AD is equal to AB. You have to produce this BA, it should be straight. How much you have to produce? It has to be produced to a point D such that AD becomes equal to AB. And then you have to prove that angle BCD. Right now, this angle BCD is not formed in the figure. How will you form that? How will you complete that angle? By joining C to D. This larger angle therefore formed at vertex C, angle BCD. There are some other angles also formed at C. You can name angle BCA. We also have angle ACD. We are not asked about those two angles. What we are asked is angle BCD. We have to show this angle is a right angle. What do you mean by a right angle? You have read, yes, it is an angle of 90 degree. An angle of 90 degree is called a right angle. So we have to show angle BCD is equal to 90 degrees. As usual, given part of the solution you will get from the textbook. I have just now said up to AD equal to AB, you have the given part of this question, and that is followed by to prove angle BCD is a right angle. To prove is also there. I shall explain here the proof of this. Well, as we begin the proof of this, you recollect one of the results we have read in Euclid's axioms, first geometry chapter, lines and angles. One of the Euclid's axiom we have read there, things which are equal to the same thing are equal to each other. This we have to apply here before we begin the main solution. We have, according to the statement, AB equal to AC. It is given to us. We also have AB equal to AD. This is also given to us. This is given. This also is given. And then, what will we do therefore? We'll apply Euclid's that axiom. Things which are equal to the same thing are equal to each other. We have here AC equal to AB. We also have AD equal to AB. That same thing is AB here. There are two things which are equal to the same thing. What are those two things? AC and AD. Therefore, the result says these will be equal to each other. So, what will you conclude therefore from here? AC is equal to AD. Things which are equal to the same thing are equal to each other. Having done this, now to prove this question, we'll consider the two triangles which are formed in the given figure one by one. Let us first consider the triangle ABC. We have, roughly I shall draw this separately here. I have triangle ABC. It has AB equal to AC. Knowing AB equal to AC, will use the theorem we have proved last time. We'll apply that here. In a triangle, if two sides are equal, then the result is their opposite angles are also equal. Angles opposite to equal sides of a triangle are always equal. Knowing AB equal to AC, what will be the conclusion therefore? Their opposite angles will be equal. Now find for yourselves which is the angle opposite to AB. Side AB has angle C opposite to it. Likewise, which is the angle opposite to the side AC? It is angle B. So the conclusion will be these two angles are equal. Had this been the actual figure, we would use short names of angle B and angle C because only one angles are formed there. But when we come to the actual figure, we find at vertex B only one angle is formed, so we can give the short name. But at vertex C there are many angles formed. Therefore, if you give the short name here, it will be confusing by angle C which angle you mean. So therefore, what shall you do? You will give the full name of that angle. Angle BCA. What do we have? AB is equal to AC. Given to you. And the conclusion therefore will be angle C is equal to angle B. As usual, we'll put the reason here why we say angle C equal to angle B, knowing that AB equal to AC. The theorem is angles opposite to equal sides of a triangle are equal. So write here the reason. Angles opposite to equal sides of a triangle are equal. We'll correspondingly mark this result as first result. We got it from triangle ABC. Next, the same result will be applied in case of triangle ACD also. I shall again draw roughly that triangle here. This is the one. A, C, D. We have AC equal to AD. We have proved it earlier by using Euclid's axiom. AC is equal to AD. The same result will be applied here also. We again have two sides of the triangle equal. Therefore, the theorem says their opposite angles will be equal. And this time, which are the opposite angles? In this figure, rough figure, you can say angle C and angle D. But when we come to the actual figure, you can name angles. Have here this point as D in the main figure, this point as C in the main figure. So you can name angle D as angle D because only one angle is formed there. But you cannot again name angle C as angle C, that will be confusing. You will have to give the full name, angle ACD. So consider this triangle also. In triangle ACD, we have AC is equal to AD. Now what will you put the reason for this? Earlier we wrote given, because that was given in the statement. Now this AC equal to AD was not given there. We have proved it in the solution part of this. We have proved it by using Euclid's axiom. Therefore, instead of given, you will write proved above. And then the result will be opposite angles will be equal. AC, opposite angle of AC is angle D, is equal to opposite angle of AD is angle ACD. The reason is same as you have written earlier. Angles opposite to equal sides of a triangle are equal. You will mark this as second. Well, coming back to this first result, you were told for angle B you can give the short name because only one angle is formed there. But the angle which is at C, you will not give short name there, you will have to give full name. I have written here short name. I change this to full name. It is ACB. Full name we have to give. Now, having proved this, we will finally apply now angle sum property to the triangle BCD, the largest triangle which is in the figure. Triangle BCD will apply angle sum property. Now, when you apply angle sum property, we'll get angle B short name can be written, plus angle D short name again can be written, plus angle BCD you'll have to give full name is equal to 180 degrees. Again, why we wrote the full name for angle at C? Because many angles are formed there. Angle BCD I wrote is equal to 180. Reason is angle sum property of triangle. Out of these three angles, we will split, we'll put in the value of angle B and angle D that we have got in the form of first and second. So we write by substituting first and second. By substituting first and second, we get. Now look at first and second. In the first we have angle B equal to angle BCA. And in the second we have angle D equal to angle ACD. We'll use for angle B and angle D values from first and second. So for angle B, what shall we write? Angle BCA. Well, you already know this angle BCA can also be written as ACB. Vertex, you cannot change the place of the vertex. Variable points, their position can be changed. B can be replaced by A can be replaced by B. So BCA can be written as ACB also. Plus, for angle D, you have to write angle ACD. Plus angle BCD will remain as it is equal to 180. And then these two angles have the same vertex. C is the vertex here. C is the vertex here. Together, these two angles, when you look in the figure, they together form a larger angle, the angle BCD. So, the sum of these two will be replaced by angle BCD. Plus angle BCD will remain as it is equal to 180 degrees. Simplifying this result, these are like terms you have read in algebra. Same signs, you will add them. Twice angle BCD is then equal to 180. What will be therefore angle BCD? 180 divided by 2 is equal to 90 degrees. That was the result to be proved. With that, we complete the solution of this question number 6 over to question number 7. question number 7. The diagrams of these two questions are not given here. If you look at the statements of all the earlier questions, diagrams were given there. These question number 7 and question 8, diagrams are not given on the textbook. You have to draw those yourselves by considering their statements. So read the statements carefully and try to draw the diagram. First thing that is given to us is that ABC is a right angled triangle in which angle A is equal to 90 degrees. So what will you draw? A right angled triangle. A triangle which has one angle equal to 90 degrees is called a right angled triangle. This is the right angled triangle. And according to the statement, the name of this triangle is right angled triangle. It has angle A equal to 90 degrees. Therefore, the vertex where 90 degree angle is formed, you have to name as A, because it is right angled at A. The remaining two vertices you can give on your own choice their names as B and C. One of those will be B, another will be C. So we have triangle ABC. Furthermore, we have AB equal to AC. This also is given to us that AB is equal to AC. I have shown those equal sides by putting two short lines on both these sides, means these are equal. We are asked to find measures of angle B and angle C. Angle B we have to find. Angle C also we have to find. We know angle A is 90 degrees. That is the diagram. We have drawn the diagram by going through the statement. Now what will be the given part of this? From the statement you can write that ABC is a right angled triangle in which angle A is equal to 90 degrees and AB is equal to AC. This is the given part of this. That is followed by the word find, therefore it will be followed by what we are asked to find. So this question, therefore, instead of writing to prove here, because we are not asked to prove anything or show anything, we are asked to find something. So what will you do? You will write to find here, to find angle B and angle C. Let us now try to find that. And when you have to find something, instead of writing proof we write in case you have to prove something, we here write solution. Let us begin the solution of this. And for writing the solution of this, we'll again begin with the theorem. We applied in the previous question just now. We proved the theorem previously. A triangle is there which has two equal sides. The result is equal sides of a triangle have equal angles opposite to them. Angles opposite to the equal sides of a triangle are equal. That you have to apply here. Now, which are the opposite angles of the equal sides? The angle opposite to the side AB is angle C. Opposite to AB is angle C. And the angle opposite to the side AC is angle B. Therefore, according to that theorem, angle B and angle C will be equal. Their measurements will be equal. We already know the measurement of angle A. It is 90. Now we know angle B and angle C also are equal. And then to find their measurements, we'll apply angle sum property. That will give us the solution. That will give us the measures of these. Now same thing we'll write. So let us begin with application of that theorem in triangle ABC. We have AB is equal to AC. This information is given to us, so we'll write given in the bracket. And the result therefore will be their opposite angles are equal. Angle C, angle opposite to the side AB is angle C is equal to. Angle opposite to the side AC is angle B. And the reason will be what you wrote for the previous case in the previous question. Angles opposite to equal sides of a triangle are equal. Angles opposite to equal sides of a triangle are equal. You have just now written that as reason in the previous question also. These two angles are therefore equal. Now, besides these two, I have just now said measurement of third angle is given to us 90 degrees. Now it will help us to get the measures of both angle B and angle C. To find, we have to apply angle sum property. So right now, angle A plus angle B plus angle C is equal to 180 degrees. What is the reason? Angle sum property of triangle. The result that we got earlier, you can mark as first. Angle B equal to angle C. We mark it as first. And now substitute that first here. We also will substitute the value of angle A, we know is 90 degrees. So angle A will be 90 degrees. Replace angle A by 90. Plus angle B will keep as it is. Plus for angle C, now in first we know angle C is equal to angle B. We'll replace angle C by angle B is equal to 180 degrees. We substituted the value of angle A, we know it is 90. Angle B we did not change, we kept it same. And for angle C we wrote angle B because in first we have already proved angle C is equal to angle B. So we replaced it. Now as we proceed, we find these two are like terms. Angle B and angle B, will combine them. Thus we'll have 90 degree plus twice angle B is equal to 180. Transpose 90, will be left with twice angle B equal to 180 minus 90, that is equal to 90 degrees. And finally, to get the measurement of angle B, transpose 2 also. It will be 90 degree divided by 2 means 45 degrees. Measurement of angle B is therefore 45. And then what will be measurement of angle C? In first again we know angle B is equal to angle C. Now angle B being 45, the measurement of angle C also will be 45. So we'll write by substituting in first. We get angle C is equal to 45 degrees. That completes the solution of this question. Then next question, the last question of this exercise. Question number 8. Again, you have to draw the diagram of this question yourselves. You have to show that the angles of an equilateral triangle are 60 degree each. What you will draw? An equilateral triangle. Let us name the triangle ABC. It is given to us. It's the only information that you have, that a triangle is an equilateral triangle. Now, which triangle we call an equilateral triangle? The one which has all the sides of equal length. Therefore, I have put two short lines on all the three sides, meaning those are equal in length, and therefore the triangle is an equilateral triangle. Now we have to show that each angle of this triangle is 60 degrees. What will you write as given for this question? I said just now, an equilateral triangle ABC. That is given to you. You can note down. An equilateral triangle ABC. And what are you asked to show? Means to prove. Wherever we have the word show or prove, we write the word to prove for that. We have to prove each angle is 60 degrees. Then proof. The proof of this question will also involve the application of the same theorem. If two sides of a triangle are equal, their opposite angles also are equal. Now, if we consider the sides AB and AC of this triangle, those are equal. First, let us consider these two sides. Third side, let us forget for the time being. Two sides are equal. Their opposite angles will be then equal. And then, next we'll choose the sides AB and BC. Now, this time we'll forget about AC side. We'll choose AB and BC side. Then the theorem says, again, their opposite angles will be equal, will give us angle A equal to angle C. And if you then choose the sides BC and AC, another pair, their opposite angles also will be equal. Knowing these angles are equal, we'll then apply angle sum property and get the measurements of different angles. So let us begin. We have in triangle ABC, we have AB is equal to AC. It is given to us. So write in the bracket given. And therefore apply the theorem. According to the theorem, their opposite angles will be equal. Find out the opposite angles. Angle opposite to side AB is angle C. Will be equal to side opposite, angle opposite to side AC is angle B. And the reason is same that you have put in the previous two questions. Angles opposite to equal sides of a triangle are equal. You will put that here. You will write that here. Mark it as first. Now instead of side AB and AC, choose the pair AB and BC. In triangle ABC, we have, so what shall we do now? Instead of AB and AC pair, we'll use AB and BC. Again, it is given to us. Therefore, apply the same theorem again. Their opposite angles will be equal. Find out their opposite angles. Angle opposite to AB side is angle C is equal to angle opposite to BC side is angle A. The reason is same, and you will mark this as number 2. Having done this, now apply angle sum property. Now, angle A plus angle B plus angle C is equal to 180 degrees. Angle sum property of a triangle. And then in this result, substitute both first and second. So write by substituting first and second, we get. So let us substitute. We know angle C is equal to angle B. Therefore, instead of angle B, we'll write angle C here. In second, we know angle C is equal to angle A. So what shall we do? We'll replace angle A by angle C because these are equal. For angle A, you'll have angle C plus, for angle B also you have angle C plus, we have angle C again there. For angle A, we wrote angle C. For angle B also we wrote angle C. Angle C is already there. So that also is there. Is equal to 180. These are three like terms, again, like in the previous question. But this time you have three, there you had only two like terms. Here we have three like terms. Combine them, you'll get 3 angle C is equal to 180. Transpose C, you will get angle C equal to 180 by 3 means 60 degrees. Measurement of angle C we got therefore. Now use this measurement of angle C in first as well as second. When you use it in first, what will you get? Replace angle C by 60, you will get angle B equal to 60. Use this in second, replace angle C again by 60, you will get angle A equal to 60. So therefore, you will get from first and second we have angle B equal to 60 degrees and angle A equal to 60 degrees. In this we proved each angle of the equilateral triangle is 60 degrees. With that, the exercise is over. Now we will begin the next exercise, and for next exercise we have two theorems. Today I will explain the two theorems. The proofs of the theorems I will help you to understand those tomorrow. The statements of the two theorems we will discuss today. The statement of theorem number 6, it is 6.4 there because chapter number is 6, theorem number is 4, fourth theorem of 6th chapter. This theorem is called Sss Congruence Rule. Earlier we came across Sss Congruence Rule, which was an axiom, and Asa Congruence Rule, which was a theorem. We proved it that time. Now we have Sss Congruence Rule. This theorem states that if all the three sides, because we have here S written thrice, S represents side, means if all the three sides of one triangle are equal in length to the corresponding sides of another triangle. There are two triangles. The lengths of sides of one triangle are equal to the corresponding lengths of the corresponding sides of another triangle. For example, we have two triangles. First triangle we call as ABC, and the measurements of sides, suppose we have 2 centimeter, 4 centimeter and 5 centimeter. First triangle. Another triangle, suppose we have PQR. And in this the measurements are 2 centimeter, 4.5 centimeter, 5 centimeter. So what do we find? The lengths of the sides of first triangle and the lengths of the sides of second triangle, are those equal? We have one of the sides of this triangle 2 centimeter. Here also we have one side of length 2 centimeter. They are equal. Corresponding sides we call such sides. Another side of 5 centimeter we have in here also, in this triangle also, second side of 5 centimeter. But the lengths of the third sides are not equal. Statement says if the lengths of all the three sides of one triangle are equal to the lengths of the corresponding sides of another triangle, then only the two triangles are said to be congruent. These two triangles we cannot consider are congruent triangles because the third side, length of third side in the two triangles, those are not equal. Only two sides, lengths of only two sides are equal. But that does not help us to understand, to conclude that the two triangles are congruent. Unless the lengths of all the three sides are not equal, we cannot say the two triangles are congruent. Now, had instead of 4.5 centimeter, this side also been 4 centimeter. Now, what would we mean? The lengths of all the three sides of first triangle are equal to the lengths of the corresponding sides of another triangle. Then we can say the two triangles are congruent. And since here, out of the 6 elements of this triangle, which 3 are involved? 3 sides are involved. What is left? 3 angles are left. 3 angles here also are left. When we say these two triangles are congruent, then according to CPCT, what will we conclude? That their corresponding angles will be equal. three results we will get as per CPCT. Because we have three pairs of angles. Angle A will be equal to which angle of that triangle? You have to find which is the corresponding angle of A there. And how will you understand which is the corresponding angle there? You have to find what are the arms of angle A. Angle A, arms are AB and AC. Their lengths are 2 cm and 4 cm. We have sides of 2 cm and 4 cm here also. Side of 2 cm length is PQ. Side of 4 cm length is PR. Which angle do these PQ and PR form? Angle P. Therefore, the corresponding angle of A is angle P here. And similarly, angle B, the corresponding angle of B is angle Q, and the corresponding angle of C is angle R. Therefore, according to CPCT, we'll have angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. The result will prove tomorrow. With that, we'll conclude today.